Reduction and oxidation, right? So redox is a contraction of two words, reduction and oxidation. In most fields of chemistry, it has to do with forming bonds, right? And so things are bonded together, and that's what creates new compounds. In redox chemistry, bonds aren't formed, rather little tiny particles called electrons are transferred. And these electrons possess a high level of energy. And so when you transfer an electron in a very real way, you transfer energy. So redox, in a very simplistic way, is how energy is transferred through the body. So that's what we mean when we say redox. It's simply a contraction of two words, reduction and oxidation. And in chemistry class, those of you who took chemistry in high school may remember the term oil rig. Oxidation is loose, OIL. Okay. Reduction is gain. All right. So you have an electron being transferred. The reduced species or reduction is gaining an electron.
I see what they did there.
Right. You have the oxidized species, which is losing an electron. The redox signaling molecules are already made in your body. Within the cells, there are mitochondria. While the mitochondria is creating ATP, which is fuel for your cells, there are other species that spin off of these reactions called redox signaling molecules.
Okay.
These redox signaling molecules are signal for your cells to do important functions.
That's where the on-off switch that you've talked about comes into play.
Exactly.
Okay.
So these cells don't have brains. They don't get to decide what they do. They're not sentient. They don't get to make decisions.
To be told.
If they're told to do something, they do something.
Okay.
Right? And so these signals, these redox signaling molecules, enter the cell and tell the cell to do a certain thing. Yeah, one of the examples is an immune function, right? Okay. If there's an external threat to the body, a lot of times redox signaling molecules can signal for the body to respond to that external threat.
Take care of this thing, whatever it may be.
The challenge is that your mitochondrial function in a large part has to do with your lifestyle. And even further beyond that, into the genetic code that you have, right? Your genes are different than my genes, but they all kind of stem back to similar origin.
Right.
And the genetic code for humans has evolved slowly over millennia, right?
Mm-hmm.
Technology changes very quickly.
Yeah. Yeah.
And so the landscape that we find ourselves in today is very different than humans 10,000 years ago. Now, because of rapid population growth in monocrop agriculture, in order to sustain that population growth, our food is different.